Hi, I'm Tom and welcome to the second video from the series ZGP-P or the ZGX Ground Probe program. For those who doesn't know, this is a program about making and programming probes from Arduino or other microcontrollers and components and improving it over time. More info you can find in the first video in the series and in the link below. Without any further ado, I present to you the Arduino Pro ZGP-02, aka Polaris. Here is also the badge, which I made. The Polaris's purpose was to replace some parts, make it some energetically efficient, and to test it by using batteries. ZGP-02 consists of an LCD display, Arduino Uno, thermometer, 9V battery, custom-made switch, breadboard, and a bunch of colored wires. In comparison with the ZGP-01, Polaris is smaller, compact, and simpler, while having one more measurement. Now let's be more technical. The main component is Arduino Uno R3, which has the microcontroller 80MEGA328P. So we used one digital pin, 3 power pins, and 2 analog pins as you can see. And don't worry, I haven't used the broken one from the SMD edition. The main measuring device was replaced by this DHT11 sensor module, which measures the temperature and humidity. It can measure the temperature in the range of 0 degrees Celsius or 32 degrees Fahrenheit and 50 degrees Celsius or 122 degrees Fahrenheit with the accuracy of 1 degree Celsius or 1.8 degrees Fahrenheit. And the humidity can be measured in the range of 20 and 90% with the accuracy of plus minus 4 to 5%. So that was a basic improvement since the first probe. The next component is a 16x2 LCD inter-integrated circuit or I2C display with a green background and black digits, which saves energy. Just because we used an I2C display, which is a display soldered with or to another circuit, we could reduce the number of used pins. What about the usage of the display? In the first row you can see the name of the probe and the time in seconds since the activation, and in the second row you can see the measured values of the temperature in degrees Celsius and the percentage of humidity. Then I made a custom switch and so I saved some cents. The last important and new component is the 9V battery. Thus, the Polaris is the first energy semi-independent probe from the ZGP program. We expected the battery to last for 6 hours or 21,600 seconds. To test that, we did 3 tests. In the first test, the probe lasted for 21,803 seconds or just something about 6 hours and some minutes. Then we changed batteries and tested it again, and now it lasted for 32,862 seconds or 9 hours and almost 8 minutes. And that was really incredible result. Explanation for this difference, I think, was that the first battery was a little bit drained by some previous testing. For those who doesn't know, the probe counts the time in milliseconds and it uses some kind of data type to store it. It could be long, it could be integer, and we didn't know which data type it uses, and so we wanted to test it out. Firstly, we expected it to be an integer or a 16-bit number with the number range from minus 32,768 to positive 32,767. But during this test, Polaris was powered directly from the computer, as was the ZGP-01. We ran the test until 100,010 seconds or about 27 hours and almost 47 minutes when we found that the data type has to be much longer. After some searching, I found out that it was a 32-bit data type called an assigned long, which can hold up to, and this is a very long number, it is 4,294,967,295 of number storage. To put it into perspective, we can divide the number 1000 to convert from milliseconds to seconds, then by 60, 2 minutes, again by 60, 2 hours, and then by 24, 2 days. And we can find out that the probe using the unassigned long data type can count up to almost 50 days. And when I saw this, I aborted the test on those 100,010 seconds. Okay, so let's recall the main goals of this program. Polaris isn't self-sustainable, durable, and cannot store data, but is energetically independent, except the fact that you have to replace the batteries after some time, can measure, collect, and display some kind of data. In this case, it is the temperature and humidity. In conclusion, I think the testing and the probe as a whole were successful, and more than that, and I didn't think that the probe would last that long after the first test, or that everything would go so smoothly. Now, if you want to see further into this project, you can find the documentation on my website or on GitHub, if I would remember to do it as the last time. And just a small teaser for the ZGP-03 that it will be called Michael. Also, I would like to congratulate my developer friend Tawhid Game Dev, who has recently reached 500 subscribers on YouTube, which is incredible, and so congratulations and good luck. And that's all for the video. I hope you enjoyed it. Do not forget to smash the like button, subscribe me, leave a comment below, follow me on social media like Twitter, Instagram or Facebook, and I will see you next time. Hopefully it won't be in 1.5 years, but next time. Bye!